Okay, so my estimate is, now I could estimate the left altitude and the right altitude, couldn't I? And I could average them. And that's what you would do with a trapezoid, okay? If we're just looking for a ballpark, we know that this thing is going to rearrange into a rectangle with about this area. Okay? Maybe a little more than this, because the part that I'm leaving out here is bigger than the part where this goes past the curve, right? So maybe I need to raise this up to about here. So now, the area of this thing looks like it's probably about the same as the area of the trapezoid. And what's that number there? Well, that number looks like it's probably between 0.7 and 0.8. That's my honest estimate, because half would be here, right? Now, if I put half there, that looks like it's closer to 0.8 than it is to 0.7. Okay? Although 0.75 is probably a pretty good estimate, and that's kind of what a lot of people appear to use, so that would be a good estimate. Okay? So if your picture has this just a little lower, where it's about halfway between the half and the whole, 0.75 would be a great estimate, right? But 0.7, 0.8, and if your figure isn't drawn as wonderfully as mine is, you know, you might even get a 0.6 or something, okay? But it's pretty clearly not 0.6, because this is 0.6, okay? So 0.6 probably wouldn't be a good estimate. Anyhow, any estimate in that range, I would consider to be a pretty good approximation, right? So now, clearly the width of this interval is 0.3, right? And that is 0.24. So you see how quickly you could do a ballpark estimate, right? Mm-hmm. Okay? Now, you know, I gave you the information yesterday and you wouldn't necessarily have remembered it, okay? You might have had it written down, but whether that stuck in your memory from yesterday afternoon, I don't even remember yesterday afternoon, but I think I did this. Okay, so, total area is the square root of 2 pi. And you can calculate that in your head. 2 pi is 6.2848, right? 2832, okay? That's pretty close to 6.25, which ought to catch your attention because that's 2.5 squared. So this is very close to 2.5, 2.40 something. I think it rounds to 2.40. Okay, everybody do that?
My calculator?
That doesn't matter, but you know, punch it in your calculator and see, okay? So 1 over 2.5 is what? We can divide 2.5 into 10, right? If you got $2.50, how many of those do you need to make $10? 4 of them. Well, that means that this is 0.4. That's another mental calculation you ought to be able to do instantly, and it ought to occur to you in a case like this. Okay? And if it doesn't, keep doing more stuff mentally, because, as I say, you can't do mental arithmetic as well as you could if calculus hadn't been misused in your curriculum. Okay? From the time they put them in your hands when you were 2 years old, or whatever. Okay, anyhow, try to overcome that so you can think these things without having to take your hands off your mind and punch buttons in your calculator, like I don't like taking my hands off the keyboard to operate a stupid mouse when it's unnecessary, right? Takes time. It slows down, and it slows down my mental processes. It's distracting. It's distracting to have to go to the calculator. Although you should be able to think into the calculator when it's necessary, and you will be better able to do that if you think when you can think it. Okay? Just reinforces important neural circuits or whatever that happens. Okay, so anyhow, it follows then that the probability of 0.6 less than or equal to z less than or equal to 0.9 is approximately equal to 0.24 over 2.5, which is equal to 0.24 times 0.4, which is 0.096. Okay? And that's total probability. Right? Well, that is what you need to understand about the normal curve, and you should be able to construct a normal curve approximately this well and make these estimates. You know, you don't take those estimates to your board of directors and say, this is it. You do the estimates so you get an idea of what the probability is. And then you continue to think until you need to go to the computer, program it to spit out what you need, okay? And spit it out exactly. And if the computer spits out something that's far from what you think, either you screwed up the program or you screwed up your mental calculation. You need to debug that. You need to check what you did with the computer. You need to reconcile that with your mental calculations and fix it before you report it to anybody who's going to rely on it to get people to Mars safely or whatever. Okay?